All right, guys, let's get started. Okay, so we're going to get started. So let's go to Brightspace. You guys are section 2. Um, Dated the materials here. I think I did. So I posted the first assignment, right? So we're going to talk about that today. And they're connected. So homeworks 1 and 2 are connected. So we'll talk about those. We're going to continue with the LLM. So we're going to talk about masks today. If you remember, I said that I was going to do this week. So we'll start with that. Then we'll talk about tick token, which is kind of how to get from strings to numbers. So I'll show you that library. And then we'll go into the full baby GPT code, just from beginning to end. Try to understand that. And then what's left is to go over, so as you know, all of this has been either the LLM in parts or a compressed version of the LLM that I'm calling Baby GPT. But then after all of that, we should be ready to look at the full GPT, right? So this would be like a correct, full implementation, pretty much how Chat GPT works, at least as far as software is concerned, the actual architecture. And that's that GPT that I call GPT Huck Finn, right? The one that trains on the adventures of Huckleberry Finn. So we may get to that one today, or if not, we'll cover it next week. But essentially, we should be done by next week, right? So think about that, right? So we should be done with pretty much all the details of LLMs by next week, I believe. All right. So I'll spend less time, obviously, in all the details because that's what I've been doing, right? I looked at attention, I looked at everything, and these are things you're going to find inside the LLM. And so it's just about putting it together. All right. So anyway, so that's kind of where we are. So we should be wrapping up, LLMs on week 5, and then week 6 is exam 1, right? So currently we're on week 4. So we're going to have exam 1 on week 6, and it would be during the second half of that period. Okay, you'll have an hour and 20 minutes. The exam is closed notes, but you're allowed a cheat sheet. So something like this, you can write whatever you want on it. Okay. And so that's going to be the exam. You can expect like 10 questions. It's a Word document. You'll download it during the class, and then you just answer the questions. So make sure you're studying. I did provide some reading materials, so this is just related to what we're doing, right? So let's kind of see where we are. So we've done intro, we've done ML word problems, tensor operations. I assume by now you're on your 3rd pass, right? Through tensor operations. And then we have these 2, baby GPT. Well, these 3, I guess I should say, baby GPT, crawl, scrape data, and GPT's homework. So that's essentially, that the first 5 weeks of the semester. Baby GPT is what we've been working through, right? Going all through all those scripts. So we've gone over these notes here in the README, and we've done this one. I'm going to start here today. That's where the mask is. Then I think in this one background, that's where tick token is. I'll finish with this one, baby transformer. And of course, then you just have the final main GPT with every little detail. And that's going to be GPT Scratch Huck Finn. Okay, makes sense, guys? Any questions? And then I provided a Huck Finn story in there from the Gutenberg.org, so that you guys, because that code works perfectly with that one. All right, so that's kind of where we are on that. So I'll start here today. But let's just continue going over what we have in the. Oh yeah, go ahead. So as the exam. Mhm. Yeah, so I'll give you some. That's what I'm gonna. So everything we've covered, first of all, right? So everything we've covered, word problems will be there for sure. Tensor operations will be there for sure, at least a problem. And then mostly is LLMs, right? So it's either word problems, tensor operations, or anything about a GPT in particular. Yes, go ahead. Yeah, right. And that's a good point. So that takes me to the next thing. So I did provide, I've provided a lot of code, right? But I've also provided here, I believe, GPTs and homework. So I provided the Vaswani paper, right? So essentially, you can read through that one. However, I recommend that you don't start with the Vaswani paper, instead end with that one, because it's an academic paper, it's a research paper, so it's going to be less approachable, if you will. I did provide this link, notes, so you click on that, and these are my notes on GPTs. Okay, so it's got like every topic, attention, embeddings, numpy arrays, masks, positional encoding, tokens, inputs and outputs, and then it describes the Huck Finn code in detail. So everything that I will say once we get to the Huck Finn code is here. But as you know, all the tensor operations we've been doing have been related to this as well. Does this make sense?
Yeah. So like distributed.
Yep.
For example,
Sure. If I ask for code, it'll be, I'm not looking for perfect code, so I don't expect that. And usually it's gonna be something that's 20 lines of code or less. So never more than that. I'm just looking for your understanding. So one question that comes to mind that I could probably ask is the attention mechanism, right? What we covered last week. Do you guys remember? So what would you say about attention? You start with X, right? And then weights and biases, a matrix multiplication. X becomes what? QKV. And then what happens? Q times K, right, becomes the attention scores, and that's a dimension 40 by 40. Yeah. And that's where the model, as it's learning, it's going to learn those weights to know what to pay attention to. Then what do we do with the attention scores? Multiply it, matrix multiplication times V. And then it becomes, again, a vector of, what is it? 32 by 40 by 64. Remember that why do we, one of the reasons why we convert X to KQ is, you could argue, to give it more room to think, but also because we compress it, correct? The creators of Google decided that instead of having one attention of size 512, they'd rather have 8 parallel attentions of size 64. And then that gets concatenated. Do you see that? So something, yeah, go ahead.
So basically, something like.
Yeah, understanding. So to me, understanding, so you can explain things with 3 sentences or 4 sentences, but to me, understanding is like, okay, if you understand the matrix multiplication and you know you got a tensor and and X becomes K, and that, that's like set in stone, right? That's clear to anyone. And so I may ask it from that point of view, but I could say in the question, just explain, or I'll say implement in PyTorch with no more than 20 lines, with 20 lines of code or less, how does attention work? So I would expect that you start at X, KQV, matrix multiplication, KQ, attention scores times V to come back to the final tensor. Do you see that? Yeah, so that's key. Like, that's the key thing for me. Other things are like feed forwards. Those are not that important. Understanding why we concatenate, understanding this concept of the vector space model. What's the intuition with transformations? In essence, why do we always take X times a weight matrix plus a bias to get to the next layer? That's the essence of a neural net. Yeah. Any other questions? Any other? Does that make sense? So yeah, so not everything is going to be code. I can tell you that. So I do 10 questions. So no way I can have you write code for 10 questions. So usually it's like 3, 4 at most that will be code related. And then there's usually, I'm going to have like a couple, well, I'm going to have word problems, right? So I'm going to give you like, build an IDS and tell me what X and Y are and what are the dimensions. So you can expect 1 or 2 of those probably. There will be some tensor operations in there that require you to have done all 107 problems several times. No, but there may be some, tensor operations in there. I'll look for an obscure one in there for sure. You know what I mean? So I may just grab one of the 107 that I think is either the most important, right, for understanding, or or something that I think like shifting. I may ask you to do shifting just because that makes no sense initially, but it's actually quite important for some of the things that we do. Does that make sense? So yeah, so 2 word problems, 1 or 2 tensor operation, that's 4 already. 3 coding ones, so that's 7. And then, the other 3 could be explain or why this or something like that. Any other questions, guys? No other questions? All right. Yeah, so definitely go through all the code that we've done, go through all the exercises, everything like that. And then make sure to read this document. I took the Huck Finn code and just like explained everything. So it's exactly that. And I'll cover this starting next week, most likely. Yeah, please. I just show you. So you go here to table of contents. And this will be the last module before the exam. That should move. Okay. So exam 1 is coming up on week 6. And on this one, GPTs and homework. If you click on notes, it's that one. Yeah. So go on notes and, you'll have all this. So you can look through it and just read through it. And then I provided some links, and the links just take you to the code that we've already covered in class. So that's essentially what's going on. This just explains everything in more detail, the attention. These things should be familiar to you because these are the things that we've done already, but it just breaks down, all the details. You can probably skip encoder only models. We're not going to cover those until after the exam. That's like the BERT models. So yeah, BERT. So we can, but you can read it if you find it interesting. The data wrangling part is, it's there also. And that's, so you can read on that one. That should be more accessible because it's more like code and just, or descriptions. But in this module, I have also provided, the source, right? So it all came from this paper. Attention is all you need. I could have given you also the GPT papers and all of that, but that's just a lot of reading for you guys. And really, this is the one that describes everything. And it ties in pretty much to what I've been doing, Baby GPT or the Huck Finn GPT. It's essentially, the only thing is this is an actual research paper, so it's going to be way more technical, less approachable. But if you look carefully, this is exactly that attention code that I gave you. Do you see that? So it's just written as an equation. See, it talks about multi-head attentions, and so on. So read the paper last, I would recommend. Read the notes first, as a complementary thing. And definitely run the code by hand. And that's it. Make sense? Yeah, so this is, we're, kind of the class, as I was saying, we'll pretty much wrap up the essence or the basics of LLMs next week. Then we'll have the exam. Then we'll have we'll just dive in a little bit into neural networks, like, just basic neural networks and PyTorch. like regression type things to do a contrast between these two things. And then we'll jump into like CNN. So if you notice the class, like the first 8 weeks are like text related, and then the second half is more image related. So it's going to be obviously CNNs by then, and but we'll start with just basic neural nets and make the jump to CNNs. Then the actual advanced algorithms of for image processing, such as ResNets, UNets, and the UNet is a central element of something you may have heard already called stable diffusion, right? So we will look at stable diffusion and see how that works. And stable diffusion is an image generative model, right? So you guys, last semester, the students generated images. I don't know, for some reason, there's always somebody that wants to generate Pokemon or something like that. So there's a lot of Pokemon generation going on. But yeah, so that's kind of what we will do. And then as time permits, some special topics or something like that. Got it? All right. Yeah, great. So these are the notes, as I said. So I'm going to close these. Make sure you read them. So what you should be doing to study, go to the table of contents. My suggestion is read the intro slides, do the 15 or so word problems that are in here, right? Try to solve them. Do the tensor operations, 110 or so tensor operations. Go over every piece of code here. I'm going to close this one. In particular, this is key, right? You must understand this. That's the basic neural net. This one, the attention we've covered. Today we'll cover masks and tick token and baby GPT. And then next week we'll cover this one, Hub Fin. So cover that. And then here, read these notes, read this paper, and then you can, I'll talk about these, but I still haven't assigned the second homework, so I'm just getting ready to assign it. But I have assigned the first one. So I'll tell you about the first one, although I had discussed this before. So that's this module here, crawl, scrape, data. So I've already posted this. This is due September 29. Okay. And pardon? Can I extend the time? I can extend the time, sure. There aren't that many homework assignments in this course, but we do have these mini projects, which are a lot of work, right? So if you think about it, homeworks 1 and 2 are what? Homework 2 is to train a GPT from scratch, right? And what do you need for that? Text. So how are you going to get the text? You're going to scrape it off the web. So that's what homework 1 is. Okay, so I think I provided some notes here. So here we are, homework 1. Homework 1 is related to homework 2. You will need to crawl, scrape some text data to pre-train your GPT from scratch. You should collect enough data. You should collect data related to a specific topic, such as being a veterinary doctor, an artist, etc. So last year I made every student do a veterinary doctor, but this year I'm changing it to you can pick whatever you want. Make sense? So you're going to make a engineer GPT or a artist, a poet GPT, whatever you want. It's perfectly fine. All right, just so that means that when you scrape the web, you have to look for text for that topic. All right, so that's up to you. You can write. So as far as I don't care so much about the tool that you use, that's not really the objective. So I'm not asking you to become experts in this or even pick a very hard way of doing this. Find an easy way, right? The key thing is to understand that text data is crucial. In machine learning, it's not about the algorithms, believe it or not. You can have, even if you invent a new GPT-2 that no one else has invented, believe me, people will figure out what you did. They will, within 6 months, they will know it. And once they know it, what can they do? They can replicate it. So you've heard of this term in AI, there's no moat. Moat means like in a castle, you'd had like water around it and there was a little bridge, and the moat protected your castle, right? In AI, there's no moat, especially algorithms are not moat. You can see here, GPT, everybody knows it. It's right here. It's in my GitHub. The moat, if any, is either you have an application that your customers love, right? Has nothing to do with AI, or you have proprietary data. Do you see that? Those are the two moats in AI. So for instance, what do I mean by your customers love your application? Well, Microsoft is really well positioned for this. We use their email, we use Word, we use the operating system, Windows. None of that is AI, but we use it. Do you see that? That's the moat. Google is actually well positioned, right? They have Gmail, YouTube, Android, the Android phone. So the users use that and then they just add AI to it. On the other hand, OpenAI, what do they have? They really just have a great chatbot, right? But not really anything else. So they're actually at risk. Yeah, this is not me, this is the consensus of people saying this, right? Because they have no moat. Because you can see how many others are just trying to get their own AIs. Bloomberg did one, that Bloomberg channel or whatever it is, they did one, and so DeepSeek, right, came out recently. So there's many alternatives, right? So that's the whole point. So my point in giving you this homework is that emphasize that getting the data is pretty critical. Well, that's why I actually gave the veterinary doctor last year, because I said to the students to just scrape a place called vin.com. And vin.com is the veterinary information network, I think it's called. And it's just some person that since the 90s has been collecting, has a like uh, what do you call it? A bulletin board or whatever it's called, where people go and chat and ask questions, and they've collected all this data. And that generates, that's the value right there. So they train machine learning algorithms, and I'm sure they want to fine tune an LLM or something like that. But so that's the key, is that the difficulty of getting it, and then the difficulty of formatting it correctly and loading it into the GPT. Do you guys see that? And so that's the whole point of this. So you can use anything, Python from scratch, beautiful soup, or there's tools out there, free tools that you can use to get the text. And just that's the key thing. Keep in mind that when you train your LLM, you want to clean that data, right? That's the other problem. So if you download websites with a lot of HTML, you got to get rid of that. Filter that out. You just need the text. Does that make sense, guys? And then there's the other question of how much data should you download, right? Well, it'd be great if you had all the data in the world, but are you going to have enough computing power to process all that data? So you got to deal with those little issues. Got it? Any questions about the homework? That homework? Essentially, show me some way that the tool or the code that you use to download the data, show me that you cleaned it, and that's the data you will use for your model, and it should be specific to what you're going to train. Yeah. Or download it for scraping the data. I don't need the data. That's your data. You're going to need it in homework too. Just create a report that shows evidence that you did it. Describe the code. That's essentially it. I don't need to check every text file that you downloaded. But it'd be interesting if we see statistics, right? So eventually when you do homework too, it'll be nice for you guys to tell me, I have these many bytes or gigabytes of text. And one metric that we want to use probably is how many tokens you had in your training set. Do you see what I'm saying? So you're going to tell me, oh, I had a trillion, no, well, not a trillion, a billion words, right? And that's how I train my model. And here's the GPU cost of that, and time and things like that. Got it? All right, great. So homework one is clear, correct? There's no questions on it? All right, great. And then you'll just create a report and submit it, screenshots and some snippets, just showing evidence that you have done it. Keep in mind, do a good job because you will need this for homework two. Homework two will be pretty much just using, so I think I started writing that so I can read that to you guys. Obviously, I will give you more time somewhere before week 8, maybe around week 8, and that one you will present, okay? So that one is individual, but I do want you guys to present it and do either so remember that the way it works is that you give it a question and it provides an answer. So you can do beforehand or you can do it in real time and show us that it can answer the question, okay? All right, so that's should be this one here, GPT description homework. And there it is. So yeah, pre-train a GPT from scratch. Oh, okay. So I think for you guys, I didn't change this. Okay, so I haven't, but I'll modify this. But pre-train a GPT from scratch to be an expert GPT is what I wrote. Rules of this, PyTorch only, and I mean only my code, right? Don't just like I found this online and it's really great, right? So I want you guys to use the things that we're covering in the class, and you got to make that work. All right. Use one or more GPUs, no libraries such as Hugging Face, etc. So Hugging Face is a library for transfer learning. For those of you that take 530, you'll learn that there, okay, how to use that one. But this is your opportunity to do everything from scratch. All right. No, so I wrote that over here, no fine tuning. So fine tuning is when you pre-train a model with, let's say, massive amounts of data. The weights are no longer random, they're smart. And then you give it like additional text and fine tune it. So keep updating the weights a little bit more, right? That's a topic for 530. So no fine tuning, pre-train only. You need to scrape the data from the web. You can use any crawlers or web scraping tools. And then these are the links from last year. So I'll modify this. I think I only did it for the other class. I haven't assigned it yet, so I'll look at it again. Any questions? Yeah, go ahead.
So for the code,
So what I don't like students go and just find TensorFlow code online and also the files, and then they just like run it on their computer and that's their homework. You know what I mean? I don't like that. So instead, what I prefer is that you guys use this code. So it should be the Huck Finn code as your starter code, right? But obviously then you have to, from there, implement tick token and you have to load the data, your own data into this.
but we have to modify
You might need to modify this one. Yes.
the name.
Yes, that's the base. Yeah. So that's kind of like I always do this in all my courses. It's like a rule I have. I provide the starting code, but you can't use any other code, right? And my goal is that way, it's consistent with what we covered in the class. I mean, if we're doing a semester long on PyTorch and then all the homeworks are in TensorFlow, I mean, do you see my point? It's kind of doesn't make sense. How do you know TensorFlow? You know what I mean? So it's not like these things are trivial to learn, right? And so then I get suspicious a little. But anyway, so this way we're all on agreement, that we're all within the topics that we're covering. Any other questions? Yeah. So yes, these are more like administrative things, but the homework assignments, as you can see, are now live and you can start working through these, right? And I think if there aren't any questions, then we can start with the class for today. Okay. All right, so I'm going to go ahead and do that. Click on table of contents. I'm going to set this as a separate video.